think we might be back. The packets are flowing. Some of them will eventually reach YouTube and Twitch. Turning on that big ol' packet spigot, sending all sorts of megabits out to Twitch and YouTube right now. I think we're doing all right. So, yeah, welcome back to a little Sunday morning stream. I'm planning on mostly continuing on just some more Rust coding. It's not necessarily the most exciting thing, but we need to make some more progress on the code behind the Gimbal controller. The good news, though, is the reason for this need is that we actually have some pretty nice computer vision results that we're ready to actually hook the gimbal up to and have it track. Oh, nice. Dean confirms the bits are flowing through the pipes and out of displays. Whoa. I've got the wireless mic today, so maybe we can follow around the cat a little bit. So here I am with my coffee. And let's see. This is the actual tripod camera, just its own video feed. But I've got that split over to this other instance of OBS, which is the one we've been hacking on. And maybe I can even make this full screen. Kinda. And then kinda. That kinda works. Yeah, this is rapidly approaching the territory where I'm worrying about my computer being able to keep up, but I think we're doing all right. Oh, look at all that CPU. Yeah, but let's try this a little bit. So there are two computer vision algorithms running right now. There's an object detector called YOLO. YOLO v2 specifically is the neural net architecture that I'm running, and then the actual neural net software, like the library that's evaluating it, is called DarkNet. And then I'm using a pre-trained model, which is one of the models on YOLO's author's website, and it's the larger model trained with the COCO dataset. So it takes input images that are like 605 pixels square, I think, and has 20 categories that it classifies objects with. And then in addition to that algorithm, I'm running the correlation tracker from dlib, which is just used to sort of fill in the estimates in between object detections. So that yellow rectangle is tracking both the correlation detector output and object detector output that actually picks up a cat or something sufficiently cat-like. So if you can read the tiny text on there, you might also see some annotations. On the top left of the detection rectangles, there's some info about the neural net output. So you'll see like a p equals and then a floating point number, and that's the probability output that comes from that particular class in the neural network. And then on the top right, that PSR is the peak to side lobe ratio, which is one of the, the quality metric that comes out of the correlation tracker. So far, it does not seem to be amazingly useful. It's always kind of a large number, and it seems like when it's tracking really well, it's like above 10. When it's tracking really badly, it's like under 5. But it's so far not the most accurate metric. Those other numbers are just kind of computed from the outputs. There's age, which is the number of frames that the correlation tracker has been running since the last reinitialize. And then that area is just the like pixel space area of the rectangle. So yeah, I mean, there might be some room for tweaking still, but I think this is running plenty well enough to actually start aiming the gimbal. Like if I just try to do this by hand, I'll just be moving the camera when that yellow box gets close to one of the edges of the screen, and that's pretty much what I'll be programming the gimbal to do. except the software will be better at keeping up than I am. I'm imagining like having a region in the center of the screen where it can move around all at once and the camera just doesn't even budge. That is still subject to being able to null out the gyroscope drift, because there's a significant amount of gyro drift in the system right now, and without that being specifically nulled out, then it'll tend to kind of push the tracked object toward one side of that hysteresis box, so you'll always end up with it kind of settling against one edge of the frame. But if I can null out the gyro drift also, then I think it'll give you a nicer kind of cinematography where, you know, Tuco or whatever you're tracking can kind of move around naturally in the frame, and then we only move the camera when we need to give them more space. So the next step is working on the kind of just a middle layer in the software for the gimbal. It's this object in Rust I've been calling the gimbal polar. And the fundamental problem we're solving is adapting the gimbal's protocol, which is just sending individual coordinates back and forth at this slow drip. So we have this slow serial port we're dealing with in the gimbal, and we've got to just repeatedly ask for all the values we want to keep up to date on. So whereas the robots, they'll just spam out full Ethernet frames that have UDP packets with all the sensors, and then we just get these nice structs that have all the sensor values. So that's pretty nice, but with the gimbal, that's not what we've got to start with. The gimbal has commands where I can ask it for one value and then it replies, and because there isn't really any viable pipelining, I have to ask these commands one at a time. So the gimbal polar is effectively going to be a scheduler that deals with the limited bandwidth available. So it'll have a list of outgoing commands, it'll have a list of values that need to be sent, and that actually might need a way of collapsing values. So if we send, the same value multiple times, it'll actually only send the latest value when it actually reaches that point. And then something similar for reads, so that maybe multiple entities can request a read, and then it just kind of saves a flag indicating that that read's necessary, and then there's kind of a round-robin scheduler that just would run through all the pending reads, and when it actually gets to the next opportunity, it would just send out that read request. And so part of the complication here is that the gimbal is still this thing that I've only barely reverse engineered. I know we spent a lot of time reverse engineering it, but there's still a lot about it that we don't know yet. And so I want to simultaneously be writing some code that'll be useful right now for aiming the gimbal, but also doing something that won't make it harder to reverse engineer the rest of the stuff we need for the gimbal. So all of that seems to be pointing toward keeping pretty low-level access open. So I'm thinking about how to map the gimbal's protocol to the sort of internal message bus architecture in this Rust server that's running the robot. And I think I want messages on the message bus that indicate individual values being set or read. And then I also want commands that you can send it to indicate, hey, this specific value, I want you to make sure to poll it next time. Or even, I can think of actually two specific use cases there. One where you'd want to just, hey, I just want to have this value at some point, just asynchronously request that it gets polled at some point in the future once. But I can also see a use for asking, hey, this value, I'm really interested in all the changes to it, so just poll it as fast as you can. And then it gets added to sort of the short list of variables that always get polled. But you can imagine that that isn't something I'd want to just do indiscriminately without a way for it to expire, because then, those could just get stuck in the settings. Like, how do I know when it's time to stop monitoring a variable like that? So I think maybe it would be worth generalizing both of those into a request to monitor a variable for a particular amount of time, or like until a deadline. And so maybe there's a command where you send the command and it is guaranteed to read the variable at least once, but you can also sort of submit a request that you want it to continue being monitored until a particular time or for a particular number of seconds. And then once you've got that, those commands could either come internally from the control loop in the bot, where it'll ask for stuff that it needs, or they could be coming from the other end of the web client, where some reverse engineering software that I'm writing in the browser could be asking for more values to graph. Oh, Tuco's over there. I think the tracker lost him, but it's right over in the area where it last saw him. He is so good at those bolts. There's also still kind of an open question about how to divide the movement between gimbal motion and winch motion, because this camera will be able to aim and move around in the space. And so figuring out, oh, good job, Tuco. That was great. Figuring out how to divide it up between those two is kind of more of an artistic decision than anything else. So there might be different modes that it goes into, or it might use some data like, so we've got a LiDAR distance sensor. We've also got just the size of the detection rectangle would give you some clue about how close Tuco might be. If it detects a cat that's taking up the entire frame, then maybe back out slightly, for example. Yeah, so right there at age equals 0 means that it's getting new object detection results pretty much every frame. Not quite every frame, because if it was getting new object detections every single frame, that PSR would never update. But yeah, it looks like the stream is still alive. A nice BK in YouTube chat says they have a test on Java tomorrow. Good luck with that. And hello from India. Cool. And Podbarian is asking, can this tell the difference between a hot dog and not a hot dog? Yeah, that's a good question. I don't think I have any hot dogs around here to test it on. It's detecting... I just noticed that it thinks the rack is a refrigerator. This might be the first time it's detected a bicycle, and it's actually a bicycle. It still thinks the rug is a bed even after putting a blanket on top. Ah, yes. This is a satisfying debug display so far. Yeah. So I have no idea how accurate this is. This is saying my GPU is like half utilized, but I'm pretty sure that this metric is at least 20% baloney. Oh, okay. So there's some more questions coming in the chat. I was about ready to move on to the next thing, but I mean, I would love to answer questions. I thought I'd just started repeating myself, but maybe I haven't. So yeah, Alistair asks, what causes the PSR to change when it can't see a cat? The PSR is a metric of, for the correlation tracker, how good is the correlation? So let me see if I can give a demo. So far the PSR has not been quite as expressive as I've been hoping, but let's see if we can get it to... Oh, see, look at that. The age is increasing. So if you see that age go above 0, that means the cat detector is failing. So right there, it doesn't see that as a cat because you can't see Tuco's face anymore. But it's still tracking that general area because it's looking for that particular image rectangle. But let's see if we can bring the camera over here and trick it a little bit. I mean, I could also plug the camera into the gimbal, and we could do that. But right now, this one's a little more portable than the gimbal. So if we aim it over there, there we go. I've got Took. I also discovered that the correlation tracker was actually using a lot more CPU than I thought last time, and it was only running at like 10 frames a second. I think the correlation tracker is running full speed now, but that's still something that I could use some more debugging for. Like right now I don't actually have like a frame rate display. The closest thing I have is watching that age counter tick up at a rate that approximates 30 frames a second. But yeah, I had to compromise on the correlation tracker accuracy a little bit by turning down some of the parameters, so it would actually be a nice improvement to find a GPU accelerated version of that same algorithm, because it's a little CPU heavy right now. But this would be, you know, if I'm like holding it, this would be a pretty good location reference for the gimbal. So one of our next couple of problems to solve with this will be, well, the gimbal is going to have some steady gyro drift over time, and if we can compensate for that by looking for some kind of baseline drift that seems to be happening even when the rest of the scene isn't moving. I don't know exactly how well we're going to be able to do that automatically. I mean, maybe the first step is just to have a little slider that I use to compensate for drift, but that seems like something we should be able to do closed loop in software reasonably well. Okay, anyway, PSR. So I also added scissors to the list of objects that it would snap to, because that was a little easier to test with than Tuco. So if I hold up some scissors, it should start tracking them. Yeah. But it's not very good at seeing the scissors when I'm covering up the blades. So right there you can see age is 0. So it's getting a good object detection. And then the PSR there is not super useful. That's really just a metric of, for any of the very few frames we're getting where it doesn't detect scissors, how close of a match is the correlation detector finding. Now if I really quickly just take away the scissors, then we're just tracking that area of the screen. So you can see the age is just increasing unbounded now. And I can kind of grab that tracking region if I occupy enough of it that it starts correlating with my hand. You can see the PSR is pretty low because we're getting further away from its reference image, but if I just stay still, then it gradually climbs back up because it's, I think it has a reference image that gradually accumulates to whatever it actually sees. It's not quite in image space, it's actually done in this gradient space. Oh yeah, I also changed it so that I was using a color image before because the algorithm supports it, but to save some CPU, I'm operating on grayscale images now. So the object tracker is using color, but the detector is using color, but the tracker is in grayscale now. So maybe that answers some of the PSR question a little bit. And yeah, so the two algorithms I'm using, one is called YOLO. YOLO v2 is the specific neural network architecture. It's a type of convolutional neural net. And then the actual neural net software that it's running on is DarkNet. There are other neural net softwares that I could be using, like Caffe or, you know, there are like a dozen of them now. I haven't even kept up on what they all are. But DarkNet is the one that this one happens to be written for. And there are some kind of sort of ports of this network to other libraries, but I couldn't find any that I liked. And then I stumbled upon someone who had written a nice Windows DLL wrapper around DarkNet, so that's what I'm using right now. So that's what's giving you these rectangles on the screen. That is a neural network where you give it a square image, just a bunch of pixels, and it chugs on that for 30 milliseconds or whatever, and then it gives you out a list of rectangles that represent bounding boxes around objects that it might be identifying. And each rectangle comes with a label and a probability. The label is actually like a number. I'm looking it up in a list of names which correspond to the categories that it was trained on. So the categories come from the training data set, which in this case, it's this thing done by Microsoft Research by scraping a bunch of people's Flickr photos and copying them illegally called COCO. And that is the data set that a lot of these pre-trained networks are using, including this one. So that's the starting point. It's definitely the kind of thing where we could train our own network to identify objects specific to this space, and that would be really a cool thing to do, but it's not necessary right away. So I can get the software working using the pre-trained network and then train my own weights. Oh, Robert says the correlation algo seems kind of like the focus tracking algorithm in the DSLR. Yeah, they're probably similar. I mean, you would get similar results from using something like sparse optical flow. So yeah, they could be using this, they could be using sparse optical flow. They would identify slightly different features probably, but a similar idea. I mean, if I was actually pretending to be the gimbal, then that would have caused the camera to move, and then it would have kind of settled on this edge. So it's not a bad baseline behavior. Like if it doesn't see any actual objects that it wants to track, this at least will keep the camera stabilized on something. I mean, Thomas says training your own network is difficult. It doesn't look like it'll be that hard in this case, actually. It would just involve collecting the right data. I mean, I don't have to start from scratch. I can. There are instructions for retraining, for like regenerating the same network I'm using right now. So I could download the same data set and use the same software, but then just make my own tweaks, like add objects, remove objects, add some refinement to particular classes, that kind of thing. It's interesting that this little square area here is with low probability detecting as a screen, a TV monitor. It does seem like the correlation tracker does not want to move very quickly, like it's only searching in a nearby area, and I haven't found which parameter to tweak to increase the search area, because if you move the camera quickly, the correlation tracker gets lost pretty easily. It might also work better with a larger rectangle. Let's reinitialize it. See, that shrinks pretty easily. I also might have it just lose the track entirely if the PSR gets that low. See, that's fine. PSR is like 12, 13. See, but then I lose it, and PSR goes down to like 5, and it's just not really tracking at this point. Wow. The detector algorithm and I both thought that looked slightly cat-like. That's just a sandbag on a tripod. It's not detecting very often, but semi-often. Oh, I added the bird class to the list of classes that it snaps to, because it detects Tuco as a bird pretty often. Yeah. Yeah, no, I mean, the detection neural net right now is definitely overpowered for what I'm doing right now, but, oh, an orange. But yeah, I mean, being able to run this with some speed to spare on the GPU lets me focus on that problem later, and I'll be able to do some interesting stuff with all that extra power. So I'm certainly interested in using the object detector to do some really neat stuff later, but right now I'm just basically using it to seed the correlation tracker. maybe it's about time to dig back into that Rust code. So this is the OBS code, which you can put aside for a bit. Alright, so I had started to dig into this. It is hard to stop watching this, though. This is really fascinating. It's also very easy to record videos with this. Just hit start recording. Yeah, that's great. It really wants that window to be bigger than my screen. Good old 1080p 30 frame per second video. Alright, so we're back in this message bus definition. So messages are anything that can go, I was going to say like between components in the robot server, but to be more specific, messages are things that come out of the main controller thread. They're not always things that were originated there. A lot of these actually came from like network packets that were converted to messages, like winch status and flyer sensors, for example. But these are things which generally components other than the actual control loop will see like flowing out of the control loop toward them. So when you're in the web browser, for example, you're getting a stream of messages, and that just represents everything that's going through the main control loop. A command is a type of message. Commands are actually the subset of messages that the client can generate on its own. So the client sends a command, then the control loop processes it, and then it probably sends that command back out as a message as a confirmation that it's processed. And then, so we've got a couple of commands for the camera subsystem here. These come from the OBS plugin. Then here's the Gimbal stuff I was just working on. So Gimbal packet is just to preserve our ability to send raw Gimbal packets. I don't really expect to need to do that from anything other than like reverse engineering software, probably. There are some things other than plain old value reads or writes that will need to send the Gimbal, but I think all of that will happen, I mean, during normal operation, all that will happen from the controller thread. So that'll be stuff like turning the motors on and off. I think the controller thread should deal with that. So Gimbal packet will be sort of an escape that we can use for reverse engineering and low-level tools later. Gimbal value write and value request will be the interface for Gimbal value write will be for sending asynchronous data to the Gimbal. If you were to just like spam out value writes for the same value, then it would only take the last one. So it kind of throttles these to some extent. Whereas packets are always FIFO order, so it just sends the packets as they come in. And then the Gimbal value request will be that's the thing I was just talking about a little earlier on the stream, where I want any component to be able to ask the Gimbal poller to, hey, when next time you're at this point in the round robin polling cycle, ask for one of these values too. So I think that'll be both a value address and like the amount of time that I want to ask it for. Now I get to think about, well, what notion of time is relevant here. Since everything in the message or the command, this stuff needs to be serializable to JSON. It needs to be relevant to other processes on other computers. So these don't really get normal timestamps as part of the packets. The timestamps are actually in this wrapper, and the wrapper is converted to a connection local timestamp by the WebSocket client. So it'd make more sense for this to be a duration. And now it's just a question of, oh, do I want this to be another data structure so I can name all of this, or could it just be part of the enum? And also just thinking about the values this will take on. I'm gonna have this one use case where I just want the value like once. So I think that would be like, well, so in the control loop, I'll have some values that I want, like I'll need the value, but I don't expect them to change under normal operation. So, and that'll actually be the default category for, I think, most of the values in the gimbal, because I'd like to have a complete copy of its configuration memory, but only some of those I'll bother polling in real time. The tricky thing is, like, there's all these like hot plug scenarios. Like, what if the robot server is running and I unplug the gimbal and plug it back in, and now it's rebooted and I need to get all the values again? How do I even know about that? I think the polar will probably have some kind of timeout error that it could have internally, and maybe that invalidates the timestamp on all the values that it's internally stored. I think it should be the default in the polar that it makes sure that it has at least some representation of all the values. But that doesn't help external entities if they haven't seen those updates, because this is all about messages rather than having access to shared state. In this case, the rectangle is stuck in the corner. So in the controller, I'll probably have some values that I just request on every control loop tick, and then some values So in the control loop, it doesn't actually matter how many of these requests I send out, because each one is just going to be a function call that probably just writes to an atomic variable. It'll be really lightweight. So it's maybe more interesting to think about the messages coming from the web client. And there are kind of two use cases I have in mind there. There's one use case where the web client doesn't care at all. And this is most of the time. And so most of the time the web client doesn't care, and it's not sending any Gimbal messages. It ignores any Gimbal values that it gets. If we have some graphs open where we're trying to debug the internals of the gimbal, trying to reverse engineer new stuff, then one way to do it would be to have every animation frame on the client, we send a new request command, and then we'll get approximately the same number of values back. They won't necessarily be lined up. That might be enough. I mean, I think it would be a little better, though, to have like one command you send out to say, here's a list of stuff I'm interested in for this amount of time. I think that would be more useful for the web client. Because I don't think we have a good way of batching together lots of commands into one WebSocket packet, because that hasn't really been a necessity so far. And so if I can avoid needing that, then like for example, this camera object detection, this isn't a single object, this is all the objects. And I think this is like gimbal value write and packet. These shouldn't be very frequent. Like these are going to be only for like debugging and reverse engineering. And I'll be sending them out like a couple of these per frame at most maybe. But this, I think we need a different format for. So let's just give that a packet named after the same thing as the command, gimbal value request. Where did I put the rest of the gimbal stuff? I guess all the gimbal stuff has been in that other module. Gimbal value data, gimbal value request. I don't need address here anymore. Let's put some of these data types in this module, maybe. No, I think those do go in polar. So the layering here is such that framing is the low level here. This goes from gimbal packet to the wire protocol. This part should work. We even have test cases for it. And then above that, so protocol here is just numbers. We might have like helper functions for building particular packets later in this module. Right now it's just constants. And then polar is this middle layer that we're working on right now. And the idea here is port is the thing that you access the polar through. Polar is the object itself that lives on a separate thread. Well, not separate from everything. It's the same thread that handles UDP messages coming in, but it's separate from most of the controller. And then address, data, and request are just some little utility structures that I think we want to use here. And data is going to be, well, so address is the simplest one. That'll just be one location where a value can exist in the gimbal. It's just an 8-bit index and an 8-bit access number. Hints says reinventing PubSub one step at a time. You know, I thought about using PubSub for this, but I didn't see any benefit to that. I mean, I might end up needing something for filtering messages at some point, but right now, like, everything just wants a copy of all the messages, so it's not a PubSub platform so much as it's an in-process broadcast message bus, which isn't something I reinvented. It's something I went to crates.io and imported. So you can miss me with your reinventing the wheel snark. So address is just some place where we might find some data. Data is the address plus the actual contents. And then value request is going to be that thing we were just talking about, which is a list of addresses and a time frame. And that time frame I'm thinking might even just be an enum, like once or continuously. Yeah, actually that request thing could be an enum. And then it could just have a value, which is the actual value address. I don't think I like that though. Like the way that that would serialize and the code that that would result in, I don't think is quite as nice as just having this be a struct with an enum inside it. All right, address, data, and request. I keep going back and forth on whether this should be plural. I think it should. Cool. Gimbal value requests. I was going back and forth on whether that time frame parameter should be per value or global. And now that I'm thinking it's per value, actually, maybe this is singular and I have the other thing put it in a vac. So that's a single Gimbal value request. And then that one's plural. Great. Yeah, I mean, it's tempting to put just a duration here in seconds or something, but I think actually this wants to be something like just an enum for once or continuously, and then the continuously would time out. Just saw a comment from MakoMK on YouTube chats who says, I think that putting a blanket on top of the rug would not make it any less bed-like. That is a good point. I think we want something like that. I think we've got to export this type also. That seems better. And then for messages, we have unhandled gimbal packet, which will only be gimbal packets that aren't something we expect. So basically anything that isn't a value response will end up in there. And then if it is a value response, it goes here so that everyone can make use of it. Where is Tuco? Oh, Tuco is right next to me. Success. Yeah, that's pretty good. That area metric definitely might be something to use for, well, I don't know. I was going to say for like backing up the camera, but I think just having the box a certain distance from the edges of the screen might be more reliable. Sam asks, so if the cat is in the frame, the gimbal will center the cam to the cat square? That isn't exactly how I planned on it working. I think it would be more like if the cat is close to the edge of the frame, you pan toward the cat. Because I don't know that I want to keep him exactly in the center, because that makes for pretty boring photography. But keeping him in frame is definitely a goal. And then he would get more or less room to walk around in the frame, depending on how zoomed we have the lens set and what the focal depth is. Oh, that's a good question from Austin on YouTube chat, who asks, would I be able to go into a bit on how I'm handling and translating the various data streams and network packets between the devices? Sure, yeah. So there's an Ethernet network that all the robot components are connected to, which is separate from my main shop network. And so that is a separate little switch. It has a PC, which is the one I've been working on right here. If I open Task Manager, you should see that network. Yeah, so here's the performance monitor so far here. This is a somewhat beefy machine. It's a quad i7 with a GTX 1080, and it's getting pushed a lot right now. So this is the shop network. This is going to be the outgoing stream and any incoming cameras and stuff that we have going into OBS. And then this is the much more regular traffic on the robot network. So right now the only robot I have plugged in is the Flyer, which is up here. It's got some sensors. It's got a gimbal, which is communicating over a serial port. And the firmware has a very simple translation layer to go from that serial port to UDP. It really just takes the serial bytes, stuffs them in a UDP packet with a simple header, and vice versa. The only knowledge it has about the protocol is it has a simple state machine that can follow the packets well enough so that when a packet is ending, it can flush the buffer and send it out over UDP without introducing extra delays there. But it's pretty much just a straight shot from the serial port in the gimbal to UDP. And then this Rust server that we've been hacking on, this is actually what does all the communications between this computer and this Ethernet network. So it's looking at all the incoming packets, it's handling all the incoming sensor data as it arrives. Because we don't have like any other thick translation layer between the gimbal and the bot server, and because the gimbal, it already has this protocol where we have to ask for one value, then it responds with that one value, and we just have to keep that loop going. So that particular loop is actually going to be implemented in the Rust server. So it'll just continuously ask the gimbal for more data, and then the data that arrives will go out on this message bus where everyone can get access to it. Oh yeah, MyFreeWeb asks about the GPU stats on the task manager. Yeah, this is on a relatively new Windows build. I don't think it's on the general channel yet, but it's something you can opt into. And I updated mostly for the GPU stats here. They're not very accurate, but it's better than nothing. This doesn't go into individual threads here, does it? It goes into subprocesses. These are the browser subprocesses for the other OBS. This has a bunch of threads, which I'm not seeing here. I'm sure there are other tools that would show me the threads. I probably even have some of them installed right now, but I've got to use the bathroom, so I'm going to leave you with this for a sec. I'll be right back. I was just realizing, while we're editing message bus format, we could just include like number of nanoseconds taken by the computer vision algorithm with each result, and then that would at least give us some idea of the performance more than what we've got right now. When we have a fully trained custom neural network here, there's definitely going to need to be a cat tongue detector. Then it's going to just start seeing cat tongues and everything, but we can probably filter it out so that we only look at cat tongues that are attached to cats. Oh, Vince said they downloaded the latest Win 10 from Microsoft with MSDN last night, and the GPU stats are there. Yeah, I didn't even have to go through MSDN to get this. This is on a public build. It was just not the default public build. Yeah, sometimes I can get it to just detect the cat head, which is fine. Fuzzing the fuzzer. If you haven't seen it, I also kind of like the look of frame blending all this stuff together, so you see just kind of the average results. Let's see if I have any of those handy. How do I loop that? Is that it? Yeah, that's the video we just recorded. I also like how you can see the numbers rolling over so quickly in the sensor data here. Maybe a longer one. Oh, here I was playing with Tuke last night. Oh, Sam has a good question. They're asking, are you going to have a calibration routine for the flyer's initial setup on the ropes? I was trying to figure out how you'd pull each rope in to get the rope's initial length for calculations. You're assuming, I think, that I am going to be using the rope lengths for calculations, which I'm not. The rope lengths are completely incidental. I mean, I am measuring the velocity of the rope motion and using that for the dynamics, but the actual lengths I'm not going to be relying on because the cord is going to be stretching a lot. So my plan there is to actually just get position feedback through other means. So, for example, I'll know if the flyer is getting too close to one of the walls because the force sensors will start hitting the low end of their limits on that edge, or on the opposite edge, rather. And for Z height, I'll have a separate set of sensors for that. I've got LiDAR sensors for that. Alexander Delic says, I wish I was a cat. Yeah, Tuco seems to have a pretty good life here. In fact, let's record more of this. This is great. I was also playing with the OBS layout and added some little image watermarks on top. There's a Tuco Flyer logo and a scanlime. This seems to be running smoother on my actual screen than in the outgoing stream preview. I think that's just because my outgoing stream preview is a little bit laggy. But the recordings seem to be a full 30 frames a second. The little flashes of low probability detections are really interesting to me. It would be interesting to visualize the lower level output of the neural network. Since what it's doing to give us those rectangles, it's actually, scraping through a matrix of outputs. So the neural net takes as an input just a big square array of pixels, and then the output is actually a grid where it's divided the scene up into tiles, and within each tile it has a bunch of candidate rectangles, and then there's a process for like merging those rectangles together from the grid into the stuff that you actually see. But it would be interesting to see that precursor, like the little activations lighting up with the almost objects that are being detected in squares on the screen. Fred says I need a Tuco AF overlay. Well, soon there actually is going to be an autofocus, and then we can have the camera be Tuco AF when we've got a good lock on the cat. That would be great. Tuco AF YOLO. Yeah. Well, that's pretty good. People keep asking me about this algorithm. In case you haven't seen it yet, if you search for YOLO V2, it's this first hit, pjready.com. It is a fun algorithm. Let me make this text slightly less enormous. They've got a fun demo video. Let's make sure the audio is muted here. You can see how many persons and umbrellas it likes to detect. Really, the key feature they're showing off here is that this neural network keeps its high performance despite being able to detect a lot of objects simultaneously, because it doesn't really have a lot of processing that it does per object. It's mostly doing processing per pixel, and then it just kind of flushes out all the objects that come out of the resulting grid of rectangles. And then within this, there are a bunch of pre-trained models you can download. I'm using this one This one right here, the YOLO V2 608x608 trained on Cocoa. 63 billion floating point operations. Yeah, here's the grid that they're using. Yeah, and so you can download this and run it on Linux. It takes a little bit more work to run it on Windows, but somebody already did most of that work. And so there's, if you go to the GitHub for TucoFlyer, I have some local forks of some of the important repos for this. So there's darknet right here. So yeah, this is mostly just a modified version of that darknet repo that compiles on Windows and gives you a decent DLL interface for it. It also still compiles on Linux, so I have not tried that, but it should work. They like their CUDA 8.0. See, in this case, it would aim a little bit up. Oops. Fred asks, you may have already answered this, but is it pretty much stuck to being rectangles, i.e. is there any way to do edge selection for an object? Yeah, YOLO is all about rectangles, so the particular architecture of this neural network means that its output is fundamentally a bunch of rectangles. The training data set is not actually rectangle-based. The training data set uses vector outlines around the objects, but you'd have to have a different kind of neural network to actually detect and preserve those vector outlines. So YOLO is all about bounding boxes. Austin says, I don't know why, but the cat tongue thing is really funny to me. Well, cat tongues are awesome, right? And Tuco loves licking, so it seems like if you could detect cat tongue, that would be an especially awesome thing. Oh yeah, so good. It's kind of detecting a person for me, but not nearly as good as the cat. Cat face. See, but this is not bad as a input for framing photographs, at least, which is what this is fundamentally being used for. Okay, so if I stop recording this, then my transcode robot should give me a time lapse shortly. I have another machine that's mounted this network disk, and it just goes through and looks for stuff to time lapse and time lapses it. That's where these files came from. Oh, that's a good question. Yeah, so Fred was thinking about like doing custom skins, like custom overlays. Yeah, so the rectangles are definitely good enough for framing photographs, but yeah, if you wanted to do like any kind of augmented reality stuff on top of the detected objects, it would be nice to have better outlines. Yeah, that would be definitely an area to try some research, maybe. See if there's a way we could have some refinement stage after running YOLO, or maybe switch from YOLO to a different network architecture eventually. Oh, the X16 is finished. Yeah, so that's a little more representative of the long-term stability. You can see a little bit of yellow smudging where it has some flickers to other stable detections, but it's pretty good. I should really just upload this to Twitter if I'm logged in. Am I logged in on here? I probably am not. I am not logged into Twitter on this computer. That's fine. Okay, this is very distracting, but fun. Yeah, gimbal value right, gimbal value requests. So now gimbal value requests could just be one thing that I fling over to the gimbal processor every so often. Okay, let's maybe look at the actual gimbal polar. Okay, so the gimbal port is how we actually access the gimbal thread remotely. So gimbal polar, rather. Gimbal polar is going to be this object that is just completely owned by this one thread that the controller doesn't usually have access to, but we'll be able to split off this port so that we can send messages to it. So we have one, so these are synchronous channels. It's one of the inter-process or rather inter-thread communication primitives in Rust. So we can send fully formed packets. I used to have this gimbal command abstraction, which would have been kind of any of these things, but I think that's not the right abstraction layer to use right now. I think... So for that gimbal value requests thing, I could have that port, so the code that executes on the local thread, I could have that actually run through the request list and then write down all the requests in some kind of, like some kind of lock-free data structure, maybe with atomic operations. Actually, it might be nice just to send those all across threads, though. And I can see the reason why I used to have two different queues for this. So those packets, I want those to be somewhat rate limited. I want to just grab one when I have bandwidth to send it, and then leave the rest in the queue. The value write and the value requests, though, like I'll probably want to just drain all of them, make some changes to an internal data structure, and then send packets based on that internal data structure. It doesn't really matter whether I have a single queue with an enum that could be either of those, or if I have multiple queues, because they behave pretty similarly. I think it's a little nicer to use multiple queues. This sender is going to be redundant because all of these are going to be senders. I should probably keep that wrapped in a vac. I mean, I could take apart the vac and send them all separately, and it would be equivalent. But then the queue would have to be a lot larger, and I'd worry about it getting stuck. I think that's probably better. Let's make these not take a reference. If I consume the value, I don't have to copy it here. I think I'm just going to do this. We'll try to send those. If not, we'll just delete the error. Because we don't want these to ever block. Oh, maybe, I don't think we ever want these to block. I think blocking there would be worse than dropping the packet. Okay, that's a pretty simple port. So packet receiver is from the framing layer. That's the little state machine that actually parses out the packet headers. Star Manatee on YouTube chat says beep boop. That's a good noise. Request timestamp. Oh, okay, right. That's the last time I sent a request to the gimbal. I'm overloading the word request here. Up here, I'm using the word request to mean I want this value eventually. Down here, I'm using the word request to mean the actual specific read packet that I send. That's more specific. Last read timestamp. Okay, and let's just put the receiver side of this over here. Let's just make these all pretty big, because these are small data structures and just... Actually, making these 1024 makes them large enough to fit an entire dump of the whole gimbal's memory. That's kind of overkill even for that, because it's like 128 times 3. Let's just make it 512. These are all plenty big enough. And the consequence here is if somebody's just spamming us with gimbal packets, then eventually we'll drop packets when this buffer fills up. tempting to add a message when we drop packets up here. Haven't really decided on a proper logging system for this process yet, so right now I'm just using print line, but that's on the to-do list. These at least deserve exclamation points. So this sync channel function returns a tuple with the input and output channels. I thought I'd just do this. Oops. So this object kind of splits itself into these two halves that can be used by, this half can be used by one thread, and then this half can be used by a bunch of threads. Okay, this is just taking any packet and treating it as an unhandled Gimbal packet. What is received anything for? Oh, right. So this is receiving a buffer of stuff. The buffer of stuff could have any number of packets in it. I think that's the kind of signature we want. So the way this scheduler is intended to work is every time we get a single packet back from the gimbal, it's an opportunity to send a couple of packets that don't have a response, and then to terminate that block with another packet that does have a response, and then we wait for that next response. I think right here we should just take apart the read packets. Yeah, command get value. I'm also realizing there's this thing I've been calling in the protocol target, which is usually an axis, but I think it actually identifies the microcontroller, so there's another value that identifies the host. This thing up here should be called target, probably. So the incoming message here actually doesn't have any information about which value we were polling, which is why we need to kind of rewrap it here for it to be useful anywhere else. So look to see if this is a toast, or toast, if it's targeted to the host, and can I do that? I don't know. I think I'm better off doing it this way. Oh, this should also check to see if I'm waiting on a get value response. I think I should have an option get a gimbal value address for a pending read. I'm just forgetting the option API in Rust. I don't want to unpack it, I just want to know if it is something right now. Is some. Cool. Oh, maybe I do want to unwrap it right here. Okay, let's change this slightly. No. Oh, if I do that, that's going to take a reference to something in self, and then I'm not going to be able to call another mutable self function. Okay, I've got to pee again. Sorry, I'll be right back. I think I might return with a fresh cup of coffee, too. Oh yeah, and as Dean points out, it looks like Ben Krasnow just dropped a new video. I saw that buzz my phone, but of course I've not had a chance to watch it yet. His stuff is super good, though. Be right back. Are we back on the wireless? Just in case it was necessary for everyone to hear the noises of my grinding coffee. Went to IKEA with my friend yesterday, and we came back with a bunch of plants. For folks who haven't seen it, IKEA is sort of a weird, hopelessly large housewares store. Like, I feel like you can have relationships start and end in the course of walking through IKEA's demo rooms. But they're also pretty inexpensive, and they're actually pretty close by, so we can just walk there sometimes. If I lived in San Francisco itself, I would not be able to walk to IKEA. This is one of the perks of living not in San Francisco, which is a good place to live. I recommend it if you can live not in San Francisco. Sometimes I actually measure out the right amount of coffee. Looks like Tuco's still hanging out on that chair. I'm almost done with this. Coldness. So much coldness in here, even without the fridge door open. And then it's just like, whoa. Oh, yeah, let's bring a jacket. Oh, Tuco, you were just waiting here. Do you want a jacket? Oh, the object detector's lost him and now it's just the correlation tracker. Aw. I seem to be the only one having trouble with the cold here. Tuco seems fine. Tuco is still a high probability cat. Aw. Oh, nice. Baymax88 says, I saw your intro vid and subbed instantly. Oh, thanks. No IKEA in India. Aw. Oh, now we're tracking the chair. Tuco is down by my feet now. The correlation tracker is lost. Oh, you found a bolt, boy. Good job. Where'd you put it? Tuco just brings these bolts and puts them somewhere that's completely obvious to him, and then I just don't see them. Oh, it's under the tripod, or at least there's one. Meow. Hey, Tuke, I haven't actually thrown it yet. Oh. Let me fix the chat, sorry. I hear you, Tuco. Oh, nice, those little cubes. Yeah, those are cute. Oh, that massive objects on the floor, it's detecting as scissors. I should take the scissors out of my list. That was just for experiment. Oh, that age was an absurdly large number for a little while because the Rust server had never seen a good detection from that area. So it was comparing some large frame number against 0. Robert asks if Tuco's been detected as a sheep. Yeah, I think so. Bunny Overlord is asking, so we add more heuristics since I was here, something to do with motion tracking? There are 2 computer vision algorithms running here. There's an object detector and a correlation tracker. So you can see the difference. So the object detector is what's giving you these labeled rectangles. And then the yellow can be kind of pulled to a particular location by the object detector. But if that isn't happening, then in the interim we run a correlation tracker that just tries to find that same image region nearby. And you can see when that age value increases, if you can read the tiny translucent text there. That means that it's been that many frames since the last time the correlation tracker was reinitialized. Brr. I think I want to copy that. I'm thinking about the mutable reference there, but that only really matters if I break this logic out into another function that needs to take a mutable self reference. Darshan asks about common filters. For what? What is your goal with a common filter? If your goal is to try smoothing these rectangles over time, then that would be, my question would be, why is that your goal? I mean, it might look nicer not to have them jittering around, but it also is less reflective of what the actual detector is giving me. And it's not going to cause the camera to jitter around, because there's going to be another layer of hysteresis and integration there. Yeah, so just to be clear, there's a bunch of stuff we could be doing to smooth the detections from frame to frame. Right now, I'm not doing any of that, and that's actually good, because right now what I want is an indication of what it's doing frame by frame, because this is debug data. if there's a particular reason I'm collecting the data, then I want the filtering to reflect how it's going to be used. So for debugging, the filtering is just another thing to get in the way, and I would want a way of disabling that. For actually moving the camera itself is going to be integrating angle and position just because of the motion algorithm. So if I just have a really simple set of speeds, so if this is within like this percentage of the edge of the camera, then move it at this speed, and just have a list of those, I think that's fine. Bunny is asking, are we even keeping the overlay? I think, well, that's an open question. I mean, right now it's for debugging. It does look cool, and I think if there's a way to integrate it into the kind of end participant experience in a way that is actually good, then we should definitely do that. So maybe that means that later on there's a filtering layer that gets applied to just the visuals. The reason I haven't even started to do that in the rectangle coordinate space, though, is that I think it might be better off doing that in image space. So if we basically just motion blur all the rectangles together, then that might give something that looks better than trying to do a smooth position update. Anyway, that's an open question and not really necessary for the next couple of steps we're doing here, but it's, good to think about for later. This is another thing I was thinking about but hadn't actually had a chance to integrate in here yet. So we've got these messages coming out with gimbal value. I think it might be nice to have an indication of where this value came from. Specifically, I'm thinking it might be nice to disambiguate between something that came back from the hardware, something that we're sending, and then on the sending side, maybe it would be worth disambiguating something the client sent versus something the control loop sent. Yeah, maybe by symmetry with value request, this would be like value response. Although that's only one of the kinds of... Because the whole idea here is, well, what if you have a value packet that is not a response, that is actually an outgoing value? I mean, that could just be another parameter in this enum. I mean, it could be a different enum, it could be a parameter for the enum. Gimbal value source. I think maybe pub use star is appropriate here. I'm also thinking this might be a good place for timestamp kind of stuff, except that happens outside the message wrapper, like right there. I don't know that this is going to be super useful, but I think it might be really nice to have this data later when I'm doing gimbal debugging. Because I'm imagining a tool that I'm going to want, which is probably just going to be one page in the web interface. And you'll go there and see kind of a diff view, sort of like what I'd been using before to just like cycle through all the values in the gimbal. And I think I might color code those based on who's written them last. So response would be something that I just read back from the gimbal, and then command and controller would let me disambiguate between writes that are coming from inside the controller and from the client side. Okay. There's just a gimbal value message. Yeah. So usually this will be the last packet in the batch, and so we'll get this read response. Then after processing the batch, we'll have this opportunity, send next batch. And I think that's something we'll call, do we call that in the timeout too? Yeah, so we can call that either when we complete a batch or when we just timed out. So that's going to need to check whether we have a pending read, and if not, we'll send the next read that's queued. And that's just address and value. We check the command, the target. Oh, we need to check the framing. What did I just do with my paste buffer? Okay. Okay, so if all of that succeeds, it'll return. Otherwise, it goes to the unhandled Gimbal packet. And this should be able to get the mutable self-reference, I think. We'll see. That might be a problem. You know, this could be up here. Let's take this down to non-mutable reference. What is this, just Gimbal value? Yeah. Packet. That's not packet, that's data. Something like that. Krangus on YouTube chat asks, can I change the rectangle color based on the age to make it more obvious? Definitely, I could. I'm just not doing that yet. Again, the goal that you have is probably not the goal I have. I don't really feel the need to make it more obvious when it switches trackers right now. But, sure, that is a thing we could do. Hi, Tuco. Here you are, under my legs. So we've got the incoming packets. Send next batch should be nice. Last read timestamp. Maybe this should be a batch timestamp. Yeah, so anytime this gets called, if we receive the read that we were looking at, we'll get a call to send next batch, which will... I still have the opportunity to send a read if it wants. The main thing this timestamp is relevant for is checking timeouts. And this seems fine, like if we had an opportunity to send a read and we didn't 50 milliseconds ago, I don't think we should treat that as a timeout. So we'll be at least checking every 50 milliseconds or whatever this timeout is, which isn't normally what causes us to get to the next read. It's just if we have a communications failure of some sort, that's what keeps it from getting stuck. Yeah. So in addition to writing those batches, we need to go through and drain these queues. This was some test code I added. What even is this? 3. Oh, motor power. Okay, and inside this write next batch, we have a buffered writer here. So we can just like fill this writer with whatever data we want. And then all of that ends up in a single UDP packet, which should be pretty nice. Self.write next batch, writer. This writer comes from the caller. Where is that? I think that's the bot communication down here. Yeah, Gimbal writer. There we go. So there's the timeout check in the same loop here. And there's the Gimbal messages going out. So most of the processing related to these incoming UDP messages ends up happening elsewhere. So for example, we get a message from the winch. We just wrap that message up in this winch status and then send it out to the broadcast bus where everybody else deals with it. But because the gimbals, like a single gimbal packet does not actually give you enough information to usefully deal with that data, because you need to know what, like if you got a response, it doesn't actually include the address of the request, so you need to be able to piece those back together. So all of that ends up running inside this bot.com thread. Okay, so getting this loaded back into my head. So I think in this write next batch, we'll want to extract a limited number of messages from these queues, probably. I think what we'll want is some intermediate function that's just, like, you call it and it gives you back... I guess there's no reason to build a list of messages, though. We can just iterate over them and put them directly in our output buffer. Anyway, I need to use the restroom again, so I'll be right back. I'll leave you with the computer vision trying its hardest. Oh, was I muted that whole time? Sorry, I was waiting on the bathroom to be available, and I thought I was answering a question just then. Yeah, I was trying to answer the question about the music setup, and I might have actually had my mic muted just then. But yeah, my thought was that part of the problem is I don't want to trigger the YouTube copyright bot even accidentally, but the other part of it is that it just seems like my thought on it is people can play their own music on the client side and not be subjected to whatever random stuff I end up wanting to listen to. But like most of the stuff I listen to while I work is stuff that would probably trigger the copyright bot. If I had music that I made or that a friend made that I could put on in the background, then that would be great. But also might be a little distracting then, because then it would be kind of more about the content rather than it just being something that's ambient. So I don't know, that seems tricky, but I was also mentioning that Hedgeberg has a separate music stream, so when they stream on Twitch, but then you can also go to a separate server and get a MP3 stream. Anyway, I'll be right back. And Tuco's ready to join me over here. Hey, Tuke. Hey, Tuke, I've got a bolt. I think he has a bolt that he's interested in that's under the stove. Whoops. Darshan has an interesting question. Is there a way to associate code changes with the live stream? I mean, I don't think anybody is saving accurate enough timestamps for that. We've had a suggestion before that it would be cool to have some kind of live, like directory share, so that as I save the file, everyone can just see it in their editor. But like, if you want to get like actually as I'm typing or whatever, like that stuff doesn't usually hit the disk. It's usually just in Sublime Text's buffer. I think it's an interesting idea. I just don't have any software that solves that problem already, and it seems like something that would require writing some code. Well, we could actually just try to see if this stuff works so far. Since it's kind of in a working state, we should add a read command down here. Let's take that out. Brr. What is this protocol command? don't think those were good packets in my little example here. I think this is supposed to be I think it would be something like that, and then the values over here. Let's double check that against the saved files we have. Okay, so this is, oh, that's right. There's an extra 0 there. There's the number, then there's a dummy byte, and then there's a 16-bit value that we're packing in there. This would be some good stuff to put in the protocol. See, and there's no value right there. The response data just has that 16-bit int. How are we encoding these? Is that byte order? That is the crate we're using. Oh, Tuco brought me a bolt. Hey, Tuke. He doesn't want that at all. He very wants that. What byte order is this, little Indian? Hey, Tuke. Cool. I hear you, Tuco. I hear you so much. Oh, man. It is not the most concentration writing this code with Tuco wanting to play at the same time. Okay, complete pending read. We already know the packets framing, target, and command are right. We just need to decode the data. I think I can do that. So this is a reader that lets me iterate through the data bytes. I think I can just get my U16 from there. So this isn't much of a failure mode to worry about, but for example, if we get a packet that has all the right header parts, but the data field is just empty, for example, then we'll just drop it on the floor. But we will remember that the pending read is done, so we'll send another read. We just don't end up getting the data for that read, which is not the best failure mode, but keep it in mind. That's pretty convenient. Hey, Tuco. It might be worth putting this in that protocol.rs along with something for building these packets, though. I hear you, Tuco. I don't know, something like that. Hey, Tuco. Let's just try making that an IO result for now. Oh, this would be a great place for the address, right? Except I don't know if I want to bring this out of Polar. think this is just an 8-bit value for the write. It's weird because the protocol uses 16-bit indices for read, or no, for write, and 8 bits for read. And I originally assumed they were both 8 bits and there was a padding byte, but when we got through disassembling the firmware, it is actually using that as a 16-bit address, and it's not validating the size or anything. Ryan says he needs an automatic bolt launcher. I agree. There I was with the mute switch. I have no idea whether that was something the copyright bot would detect. Where was I? Right, UA, yeah, how big is this? Yeah, that's just a byte. Okay, so actually this one I don't even need the pack. I can just use the vec macro to construct a vec. Yeah. That's looking better. Let's make a set value while we're here. Something like that. Just stick a couple of 16-bit values together. I should probably call this get value just because that is the name of the packet that we're dealing with. Can I? Yeah, assert. Actually, this doesn't care about the target, but I just wanted to assert the framing and the command is right before I unpack it. So now I can use the question mark operator to propagate that error if I need to. guess that's all I needed. There. That should be enough to give us messages on the bus. I think the fastest way to test this is by sending out a get command every frame. That's right, so Gimbal packet has write 2. That whole thing. Let's see if that even compiles. Oh. Creator on Twitch chat says that I'm like Tony Stark. That's, oh man, but anybody can just hack at stuff and make it work, right? I'm gonna see if I can get away without the release build. I was telling folks on the last stream that I've been having to do release builds for the Rust server because the debug builds are too slow. And I think that's still the case, but since we're not testing anything that requires us to keep up with all the messages, this might still be enough. Let's just see how far it gets us. I also would like the outputs. Let's see if I can just SSH into a program that has WebSocket, or a computer that has WebSocket client. Oh, I do. Okay, so I'm SSH'd into my Mac workstation, which has this WS tool installed, which is just a very simple WebSocket client. What are we missing here? Oh, how did that happen? I guess I might not have been compiling this module before, because I think it was left out of the mod lines here. Whoa. Mm-hmm. I meant for all of these to be public. This doesn't need to be double public. I know I'm missing a bunch of imports still. Is that right? We're venturing into parts of Rust I don't know very well in the module system. Where is my framing? Oh, maybe it's like that. Oh, super. That's what it's called. Yeah, Toque definitely needs an automatic bolt launcher from Ryan in YouTube chat. Oh yeah, and then Andrew says there's sub-etha edit. Yeah, actually, so we got into a discussion a bit on like what kinds of editors would actually allow the like real-time collaborative code editing stuff. And I mean, within reason, I would try using a different editor on my end. The main thing is it would just need to support working with a bunch of local files. Like if it's something that's completely cloud-based, then it's not really useful because I need to be compiling stuff. Why can't we find gimbal framing? This is in protocol.rs. I think we're importing it up here. Did I spell it wrong? I don't think so. Oh. Right. Yeah. These might as well be separate files at this point. And there's some trait I need to import from byte order, I think. Oh yeah, read bytes ext and write bytes ext. At least now the read and write side of this is diverging slightly. Oops. Yeah, okay. I thought that might be a problem. I think we want to do this and then this. Oh, nice. Suicidal Cat asks if I have a favorite snack food other than hummus. They put themselves on a subscription for a 2-pound bag of pistachios every month. Yeah, that sounds great. Pistachios are delicious. I haven't just like eaten them out of a bag in a while. But yeah, actually to answer your question, I probably should. I don't really have a great collection of snack foods that I like right now. I like toast, but I'm always running out of bread. Does this want a reference to sum? Is that what we're missing? I could try this. I think I'm getting confused because the semantics for for loops, you give a reference to the iterator and then it iterates over references. But I think for these, what are these even called? Checked assignments or something like that? I don't know. Oh, macadamias are tasty. Right. Yeah, I need to not... Maybe I just clone it every time. I mean, this is usually going to be a good value, so there's, like, I'm not really saving a lot of work by not cloning it if it turns out to be none. Okay, cool. And 68. Can I make a cursor with a reference to that? I think this will end up making the cursor around a slice instead of around a vec, which is fine. I think that worked. Oh great, now it's giving us a bunch of constants that were never used. Ugh. I think I actually want to disable that warning for the protocol file. There's like a block level way of disabling this warning. I thought there was something less heavy duty than allow dead code. Whoa. Why did we just get a bunch of controller input queue overflows? Is it because this is the debug build? Oh yeah. I think this is because it's the debug build. We're getting the occasional frame. Every so often a frame. Oh, and then a bunch of queue overflows. Thanks. Bot controller is fighting for CPU. Alright, fine. Let's do a release build. Where is a list of all these? I'm just looking at this to see if there's like an unused const that I need, or... where's the actual list of these? That's also not the documentation. Well, I mean, a lot of these, I don't know that I'm actually ever going to use. I just want them there for documentation. Otherwise, I'd leave these warnings and they would eventually go away. But stuff like this, like, I don't think I'm ever going to be talking to the bootloader from this process. I just wanted those there for completeness. Maybe I should just allow dead code. put these in all the little constant modules here, but not pack and unpack. Ryan is asking if I've tried using a beta Rust and tried incremental compilation. I have not. I didn't know that was a thing yet. World's Ender on YouTube chat is suggesting I use sys memory replace in the standard library to replace the pending read with none. Oh, to do like an atomic, or not atomic in this case, but at least an exchange. We could do that. Now let's take a look at that function they're recommending. Oh, that's great. That is pretty much what I want, isn't it? Cool. Thank you. That makes this code a little bit cleaner. Yeah, that is a little nicer. If that compiles. Let's fix a couple of these too. I don't know why those all just came out right when I hit Control-C. So we have a couple of legit dead code segments that we can ignore for now. This one I should just go ahead and fix. That's protocol 54. Oh yeah, these writes. These writes should never fail, so I'm just going to hit unwrap on these. It should always be able to assemble one of those packets. Oh, that needs a mutable reference. Yeah, that's all work in progress stuff. So if this works, I expect to see these encoder angles coming back as fast as this can request them. You know, this actually is probably not going to work. Because I'm sending out multiple reads in one batch, which means that we're not going to be sure which one is attached to which. Okay, actually, let me kill the compile again. Let's just ask for the yaw access this time. And while this is compiling, I'm going to use the restroom again. Is that compiling? So I don't want to get too deep into web interface stuff right now, but there is a simple change we can make to the web client that would actually have it store this stuff so we can see it easily. Alright, so the messages again are gimbal value. We want to deal with these. Cool. So this bot model here is the in-memory model that the JavaScript client in our web interface. This is what it uses to take the stream of incoming messages and coalesce them into a single model. So normally it just stores stuff based on what kind of packet it is. If it's the winch, it has to store them individually based on which winch it is. So I think we need to do something similar where we're storing individual gimbal values based on which value it was. So gimbal values. I think maybe this should be one array that's per value, then an array that's per axis. Anyway, that looks like it's running full speed again. There's a cat, can't quite see it. Okay, and do we have any messages that are useful? Look at all those messages. If I grep for Gimbal, we still have a lot of messages. Oh, here we go, we're getting some unhandled Gimbal packets. Framing normal, command 6, target 3, data, blah. Why are they unhandled? That means we're ending up right here. The overlay blobs are huge. Like this whole packet right here is for the screen overlay. With all the text on the screen, they've been getting up into the like 10,000 vertices or so. It is usually info that the web client does not care about. But maybe we'll care in the future, and so far it hasn't been worth the time to actually filter things on the server side. Framing normal, command 6, target 3. Host is 3, get value is 6. Why is that not working? Oh, that's right, because I don't think I set the pending read. Let's do that down here. That data type is what now? It is an optional Gimbal address. Now it's going to be duplicating the target and the values again. This is all gradually turning into the code that's actually going to be doing this, but right now it's very, very much just a placeholder. Okay, let's see if that compiles. Let's also take a look at the WebSocket data and see if that was looking good. Oh, right. I was going to just run the old version of the binary, but I don't know that I care enough. Maybe forward progress. Alright, the Gimbal polar is going to need a data structure for keeping track of what it needs to pull. This is going to be some internal data structure. Can I do this? I don't know if that's what I want. I think I want a fixed size nested array like that. Okay, well this is running again. Oh cool, we've got gimbal values. Yay. Just trying to cut that a little bit so it's less annoying. Okay, so that's a little hard to read with all the noise, but we've got these gimbal value responses. Address seems right. This value, it's 1798 right now. This should change when I rotate the gimbal. Oh, yeah. Goes up to 3917. It is a 4096-bit, or 4000, yes, 4096-bit, 4096 count encoder that wraps around at some point. We may or may not actually experience the wrap because there's a mechanical end stop. Great. Well, maybe let's add the web side of this so it stores the values and makes them a little easier to deal with. Gimbal values. All right. Did we have that source in there? I think I forgot to check for that. Oh, it might actually be easier to just start debugging this in the browser now. All right, there's the model. So this is just a placeholder. Let's just see what happens with that. We should just see the last value show up as gimbal values. Yeah, gimbal values, and then here's the last gimbal message we received. So there's the timestamp. Great, and this is a 2-entry array. So the first entry here is where did it come from? Oh man, you know, I don't know if I like this tuple here with gimbal value source. Oh, it's probably fine though. It's just a little weird in JSON. Anyway, there's the source, there's the data. I think we just want to build our own little JavaScript wrapper around that. Like, it might just make sense to store that entire message. Like, we've already allocated the memory for it. We might as well just keep it. I'm now looking for something in JavaScript like the setDefault method in Python. I just want something that retrieves a value, or maybe like calls a function to have me create a default. What is observe here? Whoa. That's pretty strange. Find, no. Well, fine. Oh. That's right, that would be nice, wouldn't it? Using the return value of the assignment. Well, I could do something like let okay, I really don't like this. This is just cramping my style, having multiple parameters to this gimbal value. It just... Maybe this should be called like gimbal value snapshot or incoming data. Gimbal value received, maybe? Okay, so many layers of wrapping here. So this indicates some data that I have just received, including what is the data? What address is it associated with? Where did I just get it? Oh, not that. Let's try that. I think that's just going to be slightly less annoying in its structure. Gimbal polar, yeah, I know. Values. I should probably be getting these constants from elsewhere. fleshing that out enough that I can compile it. I guess they really want U-size. Whatever. Oh, I see. It wants copy trait for this because I'm actually replicating it, and I think that's totally fine. So let's just derive a copy trait for that. Oh, actually, we don't want copy, though, because copy is, like... Copy lets the compiler know that this data type is small enough that you can just copy it without even having to be explicit about it, whereas clone is always explicit. What other ways does Rust have for duplicating values like that? Is there... Huh. I could use a vec for this. Fixed size arrays in Rust are a little bit weird. Yeah, and they're just asking about copy. Ooh, more unsafe. Array vec. This is more complicated than I want to bother with for now. I know I could flatten this into a one-dimensional array, I just don't want to. That wouldn't actually help with any of these specific problems either. Is it push back? Just push. Cool. meh. A lot of this was in protocol, no, message, and scope. Tempted to add like a none option to that so that you can have a request with no scope, because that would be useful internally, but that's not something you should request. So maybe another option. Timestamped request. Cool. Sorry. Just wanted to move that out of the main constructor here. Karthik says I have a typo on line 78. think I already fixed that one. I don't always fix the typos right away. Sometimes I want to finish my thought and then I'll come back to them. But then sometimes I forget. Oh man, this complete pending read. Yeah, I guess that's also where I have to store the incoming values, because if there wasn't a pending read, I don't have any idea where to put it. It'd be kind of nice to have a data type for this. Something like that. Value request tracker. Oops. Where did it go? There it is. Okay, that's running again. We can try doing that website change now. Where are the gimbal packets? I see config. Maybe I probably saved this half-complete code, so it's just crashing every time it gets one of those packets. Okay, let's fix that. That's right, I got distracted by changing this format because I disliked it so much. So now we're getting this gimbal value received. Maybe some of this should move back to the message bus file. I don't really like having these data types buried way down here. I think we can just store it there. Let's try that. Oh, I still had a bunch of the debugging from trying to figure out the crypto problem I had earlier. That's just stuff I edited in my local node modules. It's complaining that sometimes these message handlers take a while. I think the thing that's being slow right now is this JSON object takes a long time to actually format. I don't know why it's taking that long though. That's kind of crazy. Can we get a breakpoint in here? Oh, the screen is so tiny. Oh. Did we not get a new version of this code? Oh, I'm on the wrong port. Oops. That was the stable version, not the work in progress version. I've got to copy this and then change the port. I actually already have an environment variable that lets me have the Rust server default to the port 3000. I just keep forgetting to use it, and I keep forgetting what it's called. Okay, now we've got a bunch of gimbal values here. That looks right. That's great. So we've got a timestamp every time this was updated. We've got the message, the gimbal value, the address. Yeah. Cool. So that's plenty of data for our inevitable user interface to display later. Right now it's just bogging down the web page. Okay, that's all good so far. So polar. Maybe it would make sense to flatten these. And then I would only need one counter. Yeah, I don't know. This doesn't include the value reason. I don't think this thing actually cares. I think that value, so the enum that says, did this come from the client or the server or whatever, I think that I only really care about that for debugging right now. So I kind of want these to use the same timestamp though. This will be a timestamped message. And before I send it, let's use that to update the request model. Oh, I don't have a mutable reference to self here. I could just stick that in there. I really don't like how nested that is. I don't see a really clean way of splitting that up right now, but we can come back to this. I don't know if this is going to do what I want. Like, wouldn't I need to take the reference and then index it? I don't know. Right, and then value becomes an option timestamped value. Just split that in two, maybe. See if that compiles. It really does not want to use U8 as an index there. All right. Oh. Yeah, okay. Found a little syntactic trap there, but I didn't even need that to be still a thing. Yeah. Oh. Yay. Okay, well, that's getting closer. I think the next step here is adding some code to this this Gimbal polar so that the value request tracker can iterate through this array and find the next value. Oh man, this coffee is great, but I feel like I have to use the bathroom about every 5 minutes now. I'll be right back. Oh, look at that. That'll be useful. That should come back as soon as the compile finishes, if everything works. Oh, it's still compiling. Oh man, I think I might be running a little bit low on Steam to do the live coding in front of an audience right at the moment. So I might do a little more work off stream and then come back to this later, possibly later today. Oh, but this is so satisfying. We are really close to being able to aim the gimbal, and I'm looking forward to being able to share that, so there's definitely going to be more of this soon. But yeah, I think I need to drink something warm and have a little bit of time to myself. And you get the idea, this is just going to be more turning the crank on this gimbal controller module until we get some good code out. Well, thanks so much for joining today. I enjoy sharing the coding as well as all the other parts of the process, and definitely let me know what you like on Twitter or in the YouTube comments, or if you're a patron in the Patreon messages. It's always nice to know what content is working for you and maybe what content isn't working for you. And a special thanks to all my patrons who kick in a couple bucks a month to help me buy cat food and GPUs and pay the shop rent. And that's what keeps me doing this pretty much full time. So I am grateful as long as that continues. Ah yes, and as Dean points out, there's always Gitter chat, so even if I'm not actively streaming, we can still hang out in Gitter. So if you go to that URL on the screen, gitter.im/scanlime/live, then there is a lovely little community of people there who are happy to talk about electronics or cats or whatever in between streams and during the stream. So I think I'm gonna go try to warm up a little bit and then write some code quietly, but I'll be letting folks know as soon as I hit another interesting milestone, and I'll be trying to stream this stuff at least once a day. So I'll see you folks around. Happy hacking, everyone.